When two births are randomly selected, the sample space for genders is boy-boy, boy-girl, girl-boy, and girl-girl. Assume that those four outcomes are equally likely. Construct a table that describes the sampling distribution of the sample proportion of girls from two births. Does the mean of the sample proportions equal the proportion of girls in two births? Does the result suggest that a sample proportion is an unbiased estimator of a population proportion? Now, for the entire population, assume the probability of having a boy is 1 out of 2. The probability of having a girl is 1 out of 2. And this is not affected by how many boys or girls have previously been born. So the first thing we're going to do is we're going to take this sample space, and what we can do is we can put it into StatCrunch. So we're going to open up StatCrunch here. Okay, so here we're going to say this is the first birth, and this represents the second birth. Okay, so the first sample is a boy and a boy. So if the first birth is a boy, then the second birth is a boy. And then the second sample space here is boy-girl, so we have a boy and then a girl. And then the next one is a girl and then a boy. And the next one is a girl and then a girl. Okay, so now we want to find the proportion of, in this case here, it says of girls from two births. So proportion of girls from two births. Okay, so in this case here we have a boy and a boy. Well, that means that we get 0 girls. So let's go ahead on our calculator. That means we have 0 girls in the first, 0 girls in the second, so 0 out of 2 is going to give us 0. So the proportion here is 0. Okay, if we have 1 boy and one girl, that means we get 1 girl out of the 2 births, so 1 divided by 2 is going to give us 0.5. Likewise, if we have the third scenario, which is a girl in the first birth and a boy in the second birth, again, that's 1 divided by 2, which gives us 0.5. Let's go ahead and put that in there. Okay, and then the last scenario, the fourth, is that we get a girl and a girl. That means we're going to get 2 out of 2, which is going to give us a proportion of 1. Okay, so now let's go ahead and then fill in our table here. So filling in the first table, we can see that we get a 0 for the first proportion of girls from 2 births. And we have one of those scenarios out of the sample size of 4. So therefore, this probability is going to be 1 over 4. Okay. Now the next one we have is 0.5 and 0.5. That means we have 2 of those out of the 4. So we have possibility of getting 0.5, and that probability is going to be 2 out of the 4. In the last scenario, we get a 1 out of the 4, so we're going to go ahead and put in here 1, and therefore the probability of that is 1 over 4. Okay, now keep in mind here, this is 2 over 4, so we want to reduce that to 1 over 2. And now let's go ahead and check our answer. Great. Okay, now it says, does the mean of the sample proportions equal the proportions of girls in 2 births? Okay, so let's first find the mean of the sample proportions. So we're going to go here and open up StatCrunch, and then we're going to find the mean of this column that we created, which is the proportion of girls from 2 births. We're going to go to Stat, select Summary Stats, and then select Columns. We're going to select that column of proportion of girls from 2 births, and then we're going to find the mean of that. So let's go ahead and do that. We're going to find the mean. When we find the mean, you're going to see that we get 0.5. So therefore, it's 1 over 2. Okay, now how does that compare to the population proportion? Well, the population proportion is the following. So for the entire population, okay, we're assuming the probability of having a boy is 1 over 2, and the probability of having a girl is 1 over 2. Okay, and it's not affected by how many boys or girls have been previously born. So therefore, the 1 out of 2 for the mean is the same thing as the probability of having a girl, which is 1 out of 2. So we would say yes, both the mean of the sample proportions and the population proportion are 1 over 2. Okay, now the next question says, does the result suggest that a sample proportion is an unbiased estimator of a population proportion? Okay, let's go to the definition of a biased and an unbiased estimator. A biased estimator is one that deviates from the true population value, whereas an unbiased estimator is one that does not deviate from the true population parameter. So in this case, it is an unbiased estimator. So it says, does the result suggest that the sample proportion is an unbiased estimator? We would say yes, and that's because the sample proportions and the population proportion are the same.